Okay, so here's another question from the foundation paper. Now again, this could appear in the higher paper, so it's not like it's not worth you guys doing if you're doing higher paper. It just might appear in a slightly different order. So group 1 elements, we're looking at group 1 elements, are stored under oil. Explain why group 1 elements are stored under oil. Now that word there, explain, tells you this is going to be a longer answer question. You're not going to write 2 words. You need to give a reason why group 1 elements are stored under oil. Well, let's remember what we know about alkali metals group 1. Well, we know that they're very reactive, don't we? Okay, so they're very reactive. They're going to react, as you know, if you remember that the practical we looked at, they react with water quite violently. So if if I'm storing lithium in a normal bottle and it gets damp, it's going to react. If I store potassium in a normal bottle, it will explode as the minute it gets damp. So the oil is used to protect the metals, to stop them reacting with oxygen in water or oxygen in the air. And that's what you'd need to say. So you'd need to explain, first of all, you can see here that group 1 is very reactive. And then you would need to say that the oil is stopping it reacting with the oxygen in the air. Now they've been quite generous here, allowing the word air. Sometimes they don't. Sometimes they definitely want the word oxygen, because that is the element it's reacting with. So I would get used to being specific. It's not the air itself it's reacting with, it's the oxygen within the air. Okay, here's another one from the foundation paper, slightly different. Professor Hills investigates the reactions of group 1 metals, lithium, sodium and potassium with water. Look at his observations. So lithium, it fizzes and it moves across the surface. Sodium fizzes rapidly, moves quickly across the surface. And potassium fizzes violently, moves very quickly across the surface, and a lilac flame is seen. He concludes that the order of the reactivity of the 3 metals is potassium, which is most reactive, sodium and lithium, the least reactive. Write about how the evidence from Professor Hill's observation supports his conclusion. So where's the evidence? Well, the evidence is here, isn't it? This is what he's observed. This is his evidence he's collected. And where is his conclusion? Well, his conclusion is here, isn't it? Potassium, sodium, lithium. So how does the evidence support what he's saying? Well, what evidence supports that potassium is most reactive? Well, if I look at potassium, it fizzes violently. It doesn't just fizz, it fizzes violently. They all move, but potassium moves very quickly across the surface. And also, it's the only one where we see a flame. So you could pick one of any of those things to say potassium is the most reactive because it's the only one where there's a flame, or it fizzes most violently. Now, what about lithium? So we've only got 2 marks here. So lithium, how do we have evidence that lithium is the least reactive? Well, it does fizz, but it doesn't fizz as much as the other 2, does it? It does move across the surface, but it isn't moving as quickly across the surface. So the kind of answers they're looking for are these. So the idea that potassium fizzes more than sodium, or sodium fizzes more than lithium, or potassium fizzes more than lithium would get you a mark. And then the idea that potassium moves more quickly, or sodium moves more quickly, or potassium moves more quickly so you're comparing them, aren't you? And finally, you might also mention the flame is only seen with potassium, but you'd have to say it's only seen with potassium because that's the point. The other 2 don't have flames in this example. So it's just picking out the evidence. What evidence supported his conclusion? So here's an example from the higher paper. If your foundation don't go anywhere, these things still appear on the very end of your foundation paper, and even if it isn't specifically appearing, the information that it's asking is still on your curriculum. So just because it appeared on the higher paper, do still pay attention. So this is a multiple choice question, and people seem to think that these are the easier questions because they're at the beginning and you don't have to write much, and that is just so wrong. Multiple choice questions are designed to deliberately trip you up, to make sure you really understand what you're talking about. It will often give you answers that could be right, but there's only one that's actually right. They'll deliberately say something that's very, very similar. You've really got to be confident and read the answers carefully in order to get these right. So it says here very simply, which statement is correct for a group 1 element? So I'm thinking back to my group 1 elements here. So A, it dissolves in water to form a bleach. Well, I know bleach is group 7, isn't it? That's the cleaning product, so it's not that one. Nope. It's a non-metal. Well, no, that's not right, because it's definitely not a metal. It is an inert gas. Inert means unreactive. Well, no, it's very reactive, and it's not a gas, so that's not right. Now, on the face of it, I've only got one left, but I'm still going to read it. I'm going to double check. Does it make sense? Because if it doesn't make sense, I've gone wrong somewhere, haven't I? It reacts with water to form hydrogen. It reacts with water to form hydrogen. Now, that information is not on our flashcard. I do have an add in water and it forms an alkali, but if you remember, this is why the flashcards are not perfect. It forms an alkali, a hydroxide, and hydrogen gas. Do you remember we could test that hydrogen gas to make the squeaky pop? So in actual fact, D is correct. D is correct, and D is the correct answer. There you go. But can you see how I worked through that? Even though I knew what the answer was going to be, because obviously I've done this before, I worked through each and I thought about each answer carefully. And at the end, if I'd have decided that D wasn't right, I know I've gone wrong. So rather than picking the first answer that makes sense, I've gone through each and thought, is that true? Is that false? Does it work? And I've found myself with just one answer. Now, sometimes you find yourself with a couple of answers because you're not entirely sure. But then again, you've just reduced your odds of getting it right to 50-50, haven't you? If you've definitely got rid of 2 answers, you've got a 50-50 chance of getting it right. So it's just being a little bit more savvy about what you do with multiple choice questions. Okay, then finally, I had to show you one of these. It's a longer answer question. Let's have a quick look. So it says, look at the table. It shows Kevin's results. So you can see here, I've got some metals. I've got magnesium. I've got lead, Pb. I've got iron, and I've got copper. And on this side, I've got the compounds. I've got magnesium oxide. I've got copper oxide. I've got lead oxide. And I've got iron oxide. So they're my compounds. Those are my elements. You know what's going to happen, don't you? So it says use Kevin's results to deduce an order of reactivity. Okay, so I'm looking at displacement reactions. It says use Kevin's results to deduce an order of reactivity for the metals. Now that word deduce means to come to a conclusion about, to create an order, to figure it out. So deduce something is to figure something out. So what did I say the first thing I would do if I saw a table like this to make my life easier? Well, I said I'd go in and I'd start applying some crosses and so ticks. So that's not a reaction, that's not a reaction, no reaction, no reaction, no reactions. There, lovely. Okay, and these ones here where there's writing, something's been formed, so I've got a chemical reaction here. Ah, that's much easier. Oh, that simplifies things, doesn't it? Right, okay, so I need an order of reactivity. I need to, if you remember, what did we say here? Look at the element, not the compound. Okay, so I'm looking at the elements, which are up here somewhere, this side here, guys. So I'm looking at these, not these over here. And it says more ticks, more reactive. So which one's got the most ticks? Magnesium. Okay, then iron, then lead with only 1, and copper's got no ticks. Okay, so copper's not managed to displace anything. So I've put my most reactive to least reactive. I've got magnesium, iron, lead, and copper. Now, if you've got scruffy handwriting, you need to make sure you write those really, really clearly. If the examiner can't read it, they will mark it wrong. And then the second thing I have to do, because this is a 4-mark question, so it's a lot more detailed, explain how you use the results to put the metals in order of reactivity. And this is why this is on the higher paper with the 4 marks, because you've got to give a reason why have you put them in that order using the table above. You're not going to get marks for saying magnesium's got more ticks. Okay, that's just too simple. It's true, but it's not very accurate. So why did we put magnesium first? Well, very simply, magnesium displaced more elements than all the rest, didn't it? So let's be a bit more specific. Magnesium displaces 3 elements, so it's the most reactive. Okay, now let's go back to the next one. So I would then go probably the opposite end. I could probably go to copper. Copper can't displace anything, so it must be the least reactive. Yeah? What about lead and iron? This is a little bit more complicated to phrase, isn't it? How am I going to explain this? So I might say something like, iron can't displace magnesium, so it's less reactive than magnesium, but it does displace lead, so it's more reactive than the lead. So can you see how I've tried to explain where that information has got me? So I know magnesium's more reactive, yes, because it's got more ticks, but what do those ticks mean? It means it's displaced more elements than any of the others. So you need to be a bit more specific, especially on a higher paper. You can see I've had to write quite a lot in order to get the marks there.